Hey, what's up everyone? Welcome back to another video. In the last one, we took a look at some introduction stuff as well as a high-level kind of look at the components of a database. In this one, it's going to be a little bit shorter, but we're going to start getting into, the actual hardware bit, which is the memory-based databases, so in-memory stores, versus like a disk-based database, which is perhaps what you're more familiar with. So like I said, memory versus disk. So let's talk about memory databases. So the first thing, obviously, is data is stored in memory, and so what we're talking about here is, your RAM, which is another word for memory. Sometimes you also hear this referred to as main memory. It's all the same thing, and basically, we're actually storing the data there. So even though we're storing the data there, and a really popular example of this would be like Redis, for example, which gives us the benefit of speed, which we'll touch on in a little bit. But even though that we're storing all of our data there, a memory-based database will still likely be using the disk for certain things, such as logging and recovery, and we'll also be talking more about that as we go forward. But just for now, right now, just know that for logging purposes and recovery purposes, we typically are still using the disk even in a memory database. So I mentioned performance before, and this is a large reason that things like Redis kind of come to exist, is because we need more performance out of our databases to be able to help us with caching for our applications or something like that. And we'll touch on all that later on. But so performance is definitely a lot better in memory databases or main memory databases, and this is just because of how the hardware actually works, which of course we'll also get into. Another thing that we want to talk about is that the actual data structures and the way that we organize our data and the optimization techniques are also completely different, or I don't know about completely different, but they're different in a memory-based data store than on a disk-based data store. And actually, so I'm reading a little bit ahead in this book compared to where we are in the videos. And so where I am in the book, actually, because this is a book that I'm reading, it actually talks about the way that the data is actually stored. At least I'm on the disk base right now, so I'm definitely starting to get an understanding of like what these data structures look like, and it's really cool. So I really can't wait to get to those videos. So something else we want to consider is that durability is an issue here. But actually, before that though, let's go back to this different data structures. So the reason like that we would want to do this, even though the data structures are different, so we kind of have to be programming for two different things, right? Memory data stuff and then on disk, is like I said, because the benefit is that we get better performance, and also that actually programming for memory is simpler than programming for disk, and I will go into why that's the case and how that's the case and kind of how it manifests itself in future videos. But for right now, just know that. And then the other issue is that durability is an issue. And so durability means how well your data, or I guess it means whatever it is you're working with. But in this case, how well your data is able to withstand external factors, right? So if someone accidentally, pulls the plug from the computer that your database is running on, your data is going to be gone if it's in a in-memory database, right? If someone accidentally stops the database from running, your data in a memory-based database, your data is going to be gone. Whereas if we're using disk, it might not be as fast. It might be a little bit harder to program for, but the durability aspect of things is not as much of an issue because disk is persistent storage, or disk is the word would be that disk is durable storage, but I'm trying to not use the word so that I can define what it means. Disk is more tolerant, I should say, of these external factors, right? So I guess as long as the data was saved to the disk, it won't be deleted or gone when someone quits the database or stops it from running. Whereas in the memory case, right, because the memory is wiped, so we don't have that anymore. And so this kind of goes back to what I was saying, that the disk is still used for certain things, logging and recovery, because the logs, we still need those logs, right? Like we might need to know if the database crashed, right? So all of our data that was stored by the database is no longer there, we still need to know, we need to be able to go back and check the logs and see what happened that the crash took place, right? We need to be able to know what happened if the database wasn't able to, had like a networking issue or something like that, right? And then for recovery, we need to be able to potentially recover that data as well as what I'm thinking that refers to. So that is memory-based databases. Now let's talk about disk-based databases. So disk is for storing, and memory is for caching and temporary storage. And so what that means is, and I'll actually give you like a real world example too. So what that means is that we're going to use the disk for actually storing our data, right? And so this goes back to that durability aspect of things, where the durability isn't so much an issue because a disk is, it's durable. It's not going to really suffer, or it's more tolerant of these external factors, these external events, right? But it does, in many cases, use memory for caching so that it can still speed up the access to the data, and also for temporary storage, like maybe some logs could go there. What else could be in temporary storage? Some meta information, metadata about what's currently happening in the database, right? Maybe there's some sort of state that needs to be saved or kept track of, right? So that might go into temporary storage, which we'd use the memory for. Now, a real-world example of, let me just make sure I don't talk about this now. A real-world example of this is Neo4j, which if you've never heard or used Neo4j, Neo4j is a graph database, which is a different type of database from one that is traditionally used, such as a document database or a relational database. But Neo4j, it is known for using high amounts of memory. And that said, it's still a disk-based data store, right? The reason is because the data that's stored on disk is actually put into memory so that you can very easily and quickly access and work with your data, right? And so that's part of the reason that Neo4j is such a performant database, is because it moves things into memory, right? Okay, so something that is a little bit difficult. I mentioned before that that memory-based databases are easier to work with, simpler to program for, or simpler to build in the first place, I guess, program. The reason is because data references, serialization formats, freed memory, and fragmentation in a disk-based database all have to be managed manually. And actually, more specifically, this is what the part of the stuff, the book, and other things that I'm reading about right now, because like I said, I'm a little bit ahead of these videos. That's what I'm learning about right now. So very, very excited to get there, but I think it'll be really cool, and it is very interesting to hear about when you learn about that stuff. Okay, so let's talk about durability in disk-based databases. So we can use disk as a backup, which I mentioned before, right? So potentially, and that was a recovery piece, right? So potentially we could maybe have like checkpoints or something, right, where we save to disk, right? And then another thing that we can do is a write results of an operation to a write-ahead log. To be honest, I know that this exists, and I don't quite know what it is. So I kind of skipped that in reviewing the material. So I apologize for that. But later on, I know that there's a lot of stuff that goes into this being a part of a database. So I'm definitely going to be learning more about this, and I promise I will have an answer for the question of what this is in the future. All right, so that's it for this video. I know I told you it was going to be a shorter one, and I think I hope it was. So thank you so much for watching. I hope you enjoyed. If you want to learn more about databases, definitely subscribe to the channel. I'd really appreciate that. And let me know about any questions you have down in the comments. I hope you liked the video, and I'll see you in the next one. Take care. Later.